Good morning, good afternoon. Thank you for joining us for the AWS Developers podcast, available every Friday morning in all your podcast application, Apple, YouTube, Deezer, Amazon Music, you name it. Please leave us your feedback, your stars, your little thumbs up, and tell us what you like and what you want us to talk about in the future episode of the podcast. In this episode today, we are going to talk about a native fintech, native cloud fintech. We're going to talk about technologies in the financial world with Zilch, and I have two guests, Mike Davis, your engineering manager, and Rob Nelson, your VP of engineering of Zilch. Thank you for being here. Tell me, what is Zilch?
Sure, I'll try to answer that one. Thanks for having us. So Zilch is a payments platform. We're most famous for our buy now, pay later product, but that's not the only thing that we do. We were kind of born, founded, started here in London, and the UK is our main market, and we have now 5 million registered UK customers.
What is buy now, pay later?
Yeah, buy now, pay later. It's a phrase that popped up probably about around the time Zilch was founded, around 2019, I think. It's basically a short-term loan. But it's a more flexible type of credit that people will use. It's very good for people who have maybe an irregular income. So people who are paid weekly rather than monthly, they may know that they have a paycheck coming. There's something they urgently need to buy now. They don't have the money in their bank account. They can use a buy now, pay later product to pay for everything now and pay it off over a weekly schedule. The first version of the product, and it's still our most popular version, is the ability to pay 25% of your purchase now and then pay it off in 3 further installments every 2 weeks. So it's a 6-week product. And about a year ago, we also launched a 3-month version of that product, which puts us kind of more directly in competition with credit cards that may work on a more monthly schedule.
So for me as a customer, it's an app that I can install and I can get a credit card, a virtual credit card to add to my Apple Wallet or Google Wallet on my phone and pay with that?
Yes, that's right. Although actually that's not the standard way that buy now, pay later would work. And that's one of the ways that Zilch is a bit more unique. So there are really big players in the market like Klarna, a lot of people have heard of that we compete with. But there's lots of things we do differently. So you'll see these other buy now, pay later competitors mostly on the checkout pages of online sites. And it'll be, pay with your card, pay by
installments,
or pay by Klarna or something like this. But you'll never see Zilch on the checkout page of a site like this, because what we do is you'll sign up directly with Zilch. We'll assess you for your creditworthiness, and you'll get issued with a virtual card. Many of the other providers don't do that. And then the great thing about that is you can then, like you say, add it to your Google or Apple wallet. And that means you can use us anywhere, even physically in store, where a lot of these competitors are online only. Yeah, and then when you get to the checkout page of a site, you can just fill in the card details like any other card. And that was a great way for us to initially launch because we are then instantly integrated everywhere that the card network is accepted, Visa or Mastercard. We actually started on MasterCard, and a big project we undertook this year was we migrated all of our users over to Visa cards.
And for me, as a customer, there is no fees, no interest. So how do you make money?
That's a really good question. So one of the hallmarks of buy now, pay later is that there's, the Zilch flavor of buy now, pay later is that we charge no late fees ever, and we never charge any interest either. And that's part of the reason we're called Zilch. Zilch is kind of shorthand for nothing or zero.
It's pure British slang. If you're watching us outside of UK, you probably don't know. I didn't know the name of Zilch before.
I had to explain to some of our international colleagues, what Zilch means in the British context. But it's meant to be zero. And our ideal situation is we want the user to have zero cost to use credit at all. That is true for many of the journeys through our product. Not absolutely every journey. In some cases, we charge a very small upfront fee for our product. But I say you'll never charge any late fees and never any interest.
But you didn't answer my question. How do you make money?
How do you make money? It's a really good question. So you give us all away for free. How do we make money?
That's magic.
Well, there's a really nice mechanism which other players, other websites use this, and it's called affiliate commission. So if I were to if I had a website and I advertise a retailer there and I click through,
That's something
then
we know quite well at
there we go.
Amazon. Amazon
Absolutely,
UK,
of course.
course.
The Amazon affiliate program. One of our favorites, I think, at Zilch, actually. And yeah, so we use that instead of, there are other sites and things which give this to you as cashback. Even banks do it to an extent. But we use that to offset the cost of the credit that we're lending. And we like to think it's kind of a win-win-win down the chain. So the customer gets access to free or extremely low-cost credit. The retailer only pays when a sale is made, so there's no cost up front, at least for the retailer. And Zilch sit there in the middle, and if we get our sums right, then we make money.
So as a customer, I can browse for shops on your website, and if I buy on one of your affiliate shops, you get a commission from what
That's right, yes.
Okay, I understand.
And that actually plays into one of the other aspects of our product. We're not just credit. We also, if you decide to use Zilch to pay in one go, you don't have to split it over time. You can pay in one. We will share that commission with you, and you can earn cash back instantly on the app as well.
So what are the technical constraints on such a business? You're in the payment sector, so I guess availability, compliance, latency as well. You have to, so that's the type of technical constraints you're dealing with.
All of the above,
really. Yeah. I think if you think about like trying to get the payment right, and then basically trying to get the money from the customer, that first down payment, that timing has to be really, really like
talking
tight. You know,
dozens of milliseconds maximum.
Dozens of milliseconds.
Yeah, I think it boils down to something like we have about 200, 300 milliseconds to play with because
so when I said dozen, I was way above.
We're this handshake between you that goes all the way from the merchant, and we have to validate all the way through to your bank account that you have the money to either pay in one go or pay that down payment. And that entire back and forth has to happen really fast.
But you're not a payment processor. The actual payment is done by someone else.
I don't. We'll go on, Mike.
Well, we have an issuer who issues the cards, so they deal with that part, and then we also acquire. We take the money from the customer, and so we have a third party that helps us with that. But ultimately, we have to make the decision whether or not that's the right thing to do. So we sit in the middle of all of that.
So I said in my introduction, you're born in the cloud. You mentioned 2019. Of course, the cloud was well established already at that time. So what's the technical stack you choose? Or maybe the initial one, and then where you are today?
Yeah, I'll say the initial one because I was there. So I've been at Zilch 4 years now, and I remember when I joined, it was very much one thing that Zilch and Zilch Technology do is we're very, very pragmatic. We want to, it's not an ivory tower of perfect technology. We want to get value to the customer in a safe and reliable way, right? But you can't polish absolutely every piece. So at the beginning, we were quite monolithic in our design. I believe we were spun up on an EC2 or many EC2 instances, and the idea was to have a microservice architecture from the start. But we kind of speed overtook design perfection, and one of our services became pretty monolithic. And this was maybe not architecturally perfect, but to start with, it gave us
value.
Yeah, we could deliver really fast. And it's actually, for a lot of developers, it's in that space when you're trying to change things very quickly, it's actually easier to work in that monolith. You have a single repository that you have to check out. You only have to manage one set of one service, right, which you scale up and down. And we also had an RDS instance of MS SQL. Some people think MS SQL is maybe an odd choice, but we had that.
I even didn't realize you mentioned MS SQL. But
it kind of. It was not my choice right at the beginning. I've grown to enjoy it, but the technology was a choice of our CTO who was there right at the start. He had great experience with that, understood it really well. He knew as well that he could effectively be the DBA and was confident on that platform. So that's where it's at. And it worked great. It scaled well up to a point, up to a recent point, and now we're making some changes.
I think his background was running MS SQL at scale at a stock market, market in South Africa.
It was, yeah.
So I think he's got like solid experience of scaling that.
What's the tech stack now?
I think some of that's still there. We still have the monolith in the middle. It runs on Kubernetes now.
On EKS?
On EKS, using Fargate. So,
so you don't manage the EC2 instance?
Don't manage the EC2 instances.
Serverless.
Although if you talk to the DevOps guys, they're talking about moving it over to EC2. EKS on EC2. So I think they want to start actually moving away from ECS so they can actually have that instant scaling and up and down, that kind of thing.
So that's the rationale, is to better manage the time it takes to scale out or scale in.
Because if you we kind of scale as customers like to use the product. And so often there's like peaks, like Black Friday is a really tough time for
Christmas, Black Friday,
exactly, yeah.
Amazon Prime
or even
Day.
something a bit more sudden, like a marketing push on a certain thing will then maybe the auto scaling can't quite keep up with such a set, but we know it's coming, so we can pre-plan for.
But Christmas,
like
yeah, exactly.
Yeah.
You can pre-scale for that,
Yeah.
but Fargate can't. So
That's right, yeah.
moving back to EC2 instance would allow you to pre-scale for these
Yeah.
events that are known in advance.
I think it's one of those counterintuitive choices that you make.
Mhm,
You go from
exactly.
EC2 to Fargate and then back again.
Mhm.
I think it also allows us to kind of take all those resources and put them in one place.
Can we mix Fargate and EC2 Classic in EKS? I don't know. I'm not an expert of Kubernetes.
I think
but
you can.
in the same cluster.
I just haven't done that.
Okay.
So
Okay.
they seem quite confident. It'll probably be one or the other.
You also migrated the database?
We're in the process of migrating the database. So we still have that MS SQL RDS, and we're taking each of our services and either starting the new service only on Aurora, or we're doing like something where we have half of it in RDS on MS SQL, and then using DMS to push the data across, and sort of like making a slow migration with.
So that's super interesting, because migrating a database without interrupting the service is always kind of a challenge.
tough
So
one,
you
yeah.
choose to migrate service per service using, you mentioned DMS, it's data migration service. So it's the service that allows to move data from one database to the other. How is it working?
So we've had a couple of different strategies. But Rob can talk about one, but the one I'm familiar with is to use DMS to like keep writing to the original database, and use DMS to push the data to Aurora and backfill until you're ready, and then switch it over.
So yes, so the idea is to not touch the code, to write to the old database, let DMS stream the change on the background to the new database.
Yeah.
Then I guess you run tons of tests on that new database.
Yes. Make sure everything's valid, everything's stable.
And one day or one night,
Switch it over. Yeah.
you switch over, and it's just a switch of the endpoint, like a DNS flip.
So usually
But you need to deploy your new code as well, probably. If
we usually have both at the same time.
Okay.
So it's like connected to both databases. So we can switch that way and then switch back if something goes wrong.
Exactly. I was about to ask. So you have a plan B, like you can revert back to the old.
And something
database.
which is key to a lot of our rollouts, deployments, and changes like that is we have users have launched Darkly as a feature toggling system, but it's become invaluable for this type of migration work as well. Yeah.
And there is another strategy
Yeah, I think so. Say it's a key part of our decomposition strategy because the MS SQL instance, the RDS instance, has become pretty big, difficult to manage, and also pretty expensive, right? Because we wanted read replica capability on that, you have to buy an enterprise license to do that, and you pay an enterprise license per instance that you have, so it can add up pretty quick. The RDS has been a godsend for us, the read replica has, and that's helped us to lighten the load on the main database as well. But Aurora, we really have to move to, and I think it's the strategy we've taken in some cases is actually if the team and the architects understand the data model really, really well, you can actually identify what must move on day one and what doesn't necessarily need to. So if you understand that there's a whole bunch of historical data that you don't use on a day-to-day basis, and actually the important piece is the fresh stuff coming in now, you can just leave the old data in place and just start writing new data to your Aurora instance. We've done this in our notification service, I think, recently. So this manages all of our pushes, our in-app notifications, our emails, all of this, and and it manages the database is key to the connection details as well, particularly around that in-app communication. So old connection details, they don't need to move with us. So we can run them. We can move over and just leave that, and it takes it off the critical path, which relaxes the teams, gives us more breathing room, and it's something you can kind of tidy up later. I think if you understand your data model really well, you can make those smarter decisions about how you do that migration and reduce the risk.
And what are you planning to do with these historical data?
They will be moved, and they are being moved gradually, because they probably will be exposed and used in the future for audit of what we're doing and things like this.
You don't need transaction on that, so it might move
we're
to
not transacting on that.
like Redshift or something different.
Exactly. Yeah, it can be kind of archived in that way. We have the example you gave. We'd already talked to. Yeah, you can run them actually as dual data sources, right? For our services, we're doing that in some cases. It's also quite a good opportunity to actually rethink your data model, because the initial one, so you may have done without learning the lessons that you've learned now. So now that you're splitting it out, your data model looks a bit different. And again, that means that you can't do a direct DMS migration necessarily, because all the columns, the tables, they're all different. And again, you need to do this step by step of we'll put the new stuff there, the new data model will get populated, etc., and then we'll map all the old stuff later.
Alongside with the monolith and the new services, microservices that have been built over time, you also have now an event-driven architecture. So what type of events are flowing there? What is your buzz? What are the benefits of that architecture?
So we use SNS topics, and then we use SQS to move the events around. So we have events for almost everything. So if someone's made a payment, if someone's logged in, all that kind of thing. I think I don't actually know the number, but I'm thinking 20 to 30 different events for all the different things that are happening in the system.
I think even more. I think we must be touching 50, 60, I don't know. There's
type of
so much goes on,
Anyway, there's a lot going on.
So every time something happens in the platform, there is a message broadcast on SNS. It means any new service can subscribe to these and be informed about a change in the system.
Yeah.
And then we can take action from like using a Lambda or talking to a different service. So then like notifications, it doesn't talk directly, it doesn't call an endpoint. It sends a message across the SNS topic, and notification service listens to that and sends a message. Or
it's a really good architecture pattern to decouple the different systems, make them asynchronous. It also allows to have one system maybe affected by an availability issue for a period of time and not losing event, because SQS will queue them up.
Yeah, absolutely. We get questions sometimes, why go for SNS and SQS when other people are maybe using Kafka
or EventBridge?
Or EventBridge. We touch on EventBridge in certain use cases as well. But again, there's this emphasis at Zilch engineering that this pragmatism of we have a great platform here with AWS. Why would you use something that's not provided by AWS? So SNS and SQS are right there, ready to use for us, fully managed, all of the rest. Why give ourselves the challenge of managing Kafka? Or I know AWS does it now as well, but back then I don't think that was available. And if there's no direct need to use that other technology that isn't provided by AWS, we go with the AWS option.
Yeah, most of our customers that are using the managed Kafka service are existing Kafka customers that move to AWS or extend their footprint into AWS. When you start from scratch, you of course have different choices as well. You mentioned notification, so I guess you're talking about push notification to the mobile apps, the small message that we receive on our phones. What does it involve to send push notification to your millions of customers?
I'll talk about. There's actually two interesting ones. There's maybe Mike can cover the second type. So there's push notifications, but then we also developed an in-app notification system as well, because push. They're actually different. So push is the one will buzz your phone, pop up at the top, but then actually inside the app, we never had, until we developed this in-app system, a way to as we use the word push again, but push updates directly to the app. It was always the app had to poll or check something on its own. It had to ask for updates. We never had a mechanism to push directly to it. Mike, I'm sure it's an interesting use of some of the AWS tech for that. But the pushes themselves were an interesting challenge. So at the start we worked with a third party that had their own SDK. We integrated it to our mobile app, and we used a Lambda to communicate with their APIs, and that would manage the send. So on certain events, that would get picked up by the Lambda, sent over, translated into whatever template we had, and passed over to their APIs, and then they manage everything behind the scenes.
And behind the scene, it was WebSocket or something like that?
For pushes?
Yeah.
No, it's just a REST call.
Okay.
It's a REST call to them, and then they manage over the mobile networks to
using
push.
Google and Apple's push system.
System.
Firebase,
Okay.
and I can't remember the Apple one.
Yes, and that's when we learned, and let's say my background's not in mobile development, but I've learned a lot now being forced to play with our push notifications. So there's this token which every device has and registers with through either the Google network or Apple, and that token is the key to send that push notification to us.
Basically, as a customer, when I accept that an app sends me a push notification, the phone or the operating system of the phone generates a token that you receive.
That's right.
And that's like the key that authorizes you to send me messages.
Yeah, that's it. And although it's one, it's just the one per device. But yes, you can enable or disable at an app level as well, whether you're allowed to send them or not. I think that's actually managed on the phone device itself rather than in the network. But yeah, these tokens, so they were all stored with our third party, and we had to do a migration exercise, and we wrongly assumed that they would be quite easy they would just hand over these tokens to us, and we can just start using them ourselves, because we were exploring using AWS Pinpoint to do this,
which is a managed service designed for mobile analytics and push notifications.
Exactly. So it was a great option because it gave us a lot more insight into how the pushes were performing, because the third party was a bit of a black box. Once you'd hit that API, maybe the push went and maybe it didn't, and debugging any issues was really difficult. So we wanted to bring it in-house. It was also a cheaper option for us to do that because the provider was not push only. It was push plus lots of many other things that we didn't use, because we had better ways of doing whatever they were. But there was no option to just do push. So if we went on to Pinpoint, we were paying much less, and it was, if we only wanted to use push, then that's all we pay for, I believe, with Pinpoint. So yeah, getting these tokens out was a real struggle.
So you had to deal with that third-party provider, and they had an API to actually extract the token, or you had to ask for them?
Not easily. We had to ask them and get their help to do so, and they were not particularly forthcoming in doing that.
I can imagine that.
It makes sense that way, doesn't it?
So we had to think of a smart way to regather them ourselves, and so we updated our mobile app that whenever a customer first opened the Zilch app, there'd be a handshake between us and the backend system where we'd grab that token from the mobile device.
Yes, because the token is visible from
the
app. So you can program, you can develop the mobile app to push you the token. So that's like on a flow-based migration. You capture the information.
Exactly.
But what about your customer that don't start the app?
Yeah. So the downside of this approach was if from the start of our migration, to the end, a customer has decided not to open their app, we don't have their token and we can't push to them. What we found, thankfully, though, is we gave ourselves enough breathing room that we launched that kind of, because there's no change to the app functionality to the user when we do that. That went live a good few months before we actually made the switch, and we gathered, I believe it was 90% plus of the active customer push tokens, into our system before. And we still had, we also ran an email campaign to encourage people to revisit the app and see the great deals we were offering and things like this.
It's like the carrot on the stick.
Exactly. Pull them back in. And it ended up being a really smooth migration over, and now we have much better control over those pushes.
How many tokens are we talking about? If you can...
5 million registered customers, but I believe it's about 2 to 3 million of those
tokens.
Tokenized, yeah.
And it's stored in the... I'm not familiar with Pinpoint, so is it stored in Pinpoint, or you have to maintain a separate data store like DynamoDB? Or?
It's in Pinpoint. No. We manage it in...
Yeah, we have to maintain that.
Dynamo. Aurora. One of them.
Okay.
We manage it ourselves. Yes,
yeah,
we have that.
That's great.
And we supply that when we call Pinpoint. We supply the token along with the request. Yeah.
Yes, that's part of it. So that's for the push in the sense of iOS or Android push notification. But you also implement, you said, in-app push system.
Yeah,
that's your part. How does it work?
So I mean, when you push through the Google or the Apple network, you do have limits. So you can't push to everybody at the same time, or if you wanted to send multiple notifications, you can't do that kind of thing.
And people might have it turned off, right? Like in your system settings, and we don't get actually feedback of that. We don't know how many are turned off in that way.
So we wanted like a more direct way of pushing like a notification to somebody.
So like if I have the app open and something happen, you want the app to be informed instead of the app pulling data, which puts additional stress on your infrastructure.
Or imagine something happens that you should know about as soon as you open the app.
Yeah, so like having a queue of event. So how does it work?
How does it work? So we do use like API gateway, WebSockets, and the mobile app connects to that WebSocket to API gateway, and we have Lambdas managing the connections, storing the connection IDs in DynamoDB. It's nice and scalable, so we don't have to think about it too hard. And then
keeps the Lambdas pretty busy, though, I think.
Keeps the Lambdas busy because we have like hundreds of thousands of devices connected at any particular time, and API gateway just manages that, so that's kind of nice. And then if we want to send a message, we just take the ID, the connection ID or the customer ID, look it up in the DynamoDB, and send the message.
And if the connection is not open at that time, the message stays in a queue? Or
it stays in a queue, so they can...
SQS or?
No, they can... so I think when the push happens, or when you open your mobile app, you can go look at unread messages.
It's actually it's like everyone
it cannot be SQS. That's
a
stupid question.
It's Dynamo. So it's like and we keep a status against every message. So we get a read receipt as well. So if there's a queue of these messages waiting for you, we'll query and give you the ones you've been waiting on. Yeah.
And so API Gateway is managing all the individual connections to all the app, all the customers that have the app started at a given moment.
So, I mean, you can imagine trying to run that yourself. That would be a nightmare. If you're trying to like spin up some sort of WebSocket handler or something like that on EC2, it's just really nice that you can do that on API Gateway. So,
can I ask a question about the cost of that? Because I think I remember API Gateway keeps a price per connection or per minute of connection of the
I think it's actually per message.
Okay,
so like every message that goes through, it's like
then.
That's
because if it was per minute of connection, that would be probably not an option in terms of
that might add up.
Add up a bit. That's interesting to see how you move from a monolith service to different service like that. What you describe is a microservice just for inside app application or push notification. So these are all satellite service that have been developed after the monolith.
Yeah, that's right. So it was always designed to be microservice based, but this one became much larger, and messy, hard to manage. But we followed I suppose it's at least the thought process is fairly standard. So we identified within that monolith domains of capability, and we first refactored, and we're still doing this today actually, refactored the code inside the monolith to separate them logically as well as so not like entangled into a place where they could be effectively comes like a lift and shift now outside to be hosted individually.
That's a very common practice as well. It's to have a logical group of microservices that are deployed together as one unit of deployment, effectively making a monolith. But inside, it's already ready in terms of architectural design.
But it always sounds easier when you're talking about it than actually doing it.
I can imagine that.
Especially keeping it running at the same time, and doing it piece by piece.
I think when you start, like, it's really fast to have one service. But it starts slowing you down because any change that gets made has to be deployed with everyone else's kind of changes. So
and you really see it as a manager when you've got one team. That's fine working on your big monolith. That's great. And now when we've scaled up to 8 different engineering teams, or even 9 teams now, you're now very constrained because everyone's tripping over each other in that single repository, that single service, and it makes your automated testing and your release schedule much more fragile. Because or at least it's gonna. If you want to get sure that you're going to be safe in your deployment, now it's a week-long task instead of a day-long task to do that.
So that would be an advice to wannabe startup founder or entrepreneurs to go fast. Start with a monolith because it's easier.
Yeah, I think
but then when you scale with more customer and a larger team, start to decouple things.
I think there's things you could do to make it easier on yourself further down the line. Exactly that. Start fast, and you can do that with monolith, and it's great with your small team. But at least consider the logical separation as you go, even in there, and keep your test automation up to date, and that will make your life a whole lot easier when you get to that decomposition stage.
I would love to see a book about the different times when they switch from monolith to microservices and see where the sweet spot is. Because I think everybody hits that point where it's just too big,
Is it in terms of, number of change in the system,
Yeah,
number of
something,
developers in the team?
It'd be great to know what that is.
Interesting metrics if you know, if you have if you have ideas. We cannot make or record an episode about the Developers podcast without talking about generative AI. And while we were preparing this episode, you told me about a very innovative use case, something that really matched your business model and what you try to do. So how do you use generative AI today?
Well, I think if you, Rob was talking about searching for merchants in our
So
storefront.
inside your app, allowing the user to search for a merchant.
So they're trying to find a merchant, but really they're trying to find a product. So they're looking for shoes, or they're looking for
I want to buy a new headset.
Headsets, that kind of thing.
So I'm not going to think in terms of merchant name. I'm going to think in terms of what I want to buy.
What you want to buy. So normally, I think what we were finding is people weren't looking for they were finding the names they knew instead of finding the products they wanted. So what we did on the data science team is to go and figure out a way to get those products and look at each merchant, find the products that they actually sell and that are available on their websites, and then to put that into like a vector database.
Okay, we need to split that in
several lots of different pieces.
First, very naive question: why can't you just search the catalog of your affiliates or the merchants?
Well, that's actually that's not readily available, actually, at least not in a standardized way. You could kind of crawl their sites to an extent to try and figure that out. But also, our founders, we're always very keen that Zilch doesn't become a product-based shopping app. It's not that; it's a payments app. And so we don't want kind of our storefront to be like
you're not a marketplace or something like that.
Yeah.
Mm-hmm.
And one of the I should mention it in the intro. One of the sort of the philosophy for Zilch is we want to help people. We want people to think, I want to buy this thing, and I'm going to buy it with Zilch, and that's their first thought, and that takes them to the app first, rather than...
The start of the journey is your app. So as a consumer, I need to go to your app and I need to say, okay, where I can buy this new headset. I'm taking the example of a headset.
But you already know you're paying
I bought one recently. So, so that's my starting point.
Yeah, and you already know, like at that start, you know you're paying with Zilch. That's it. What was the original question?
Let's split how to use generative AI for that. How generative AI is helping you for that use case. The original question was why you cannot search the individual merchant catalog, and you answer to that it's because you don't have an API with all your
it's not
merchants.
Standard. No, we can't get that, not easily.
So the best you can do is web scraping, which is
and then we'd have to index and standardize all those products across our search, and I just don't think I think it would be some very, very hard work, especially the number of retailers we support. The data would be, I think, pretty horrific to do.
How many are we talking about? Is it in the hundreds, thousands?
I think it's over 1,000 retailers we have.
So that's a significant work to scrape all these websites.
Yeah, exactly.
Well, I think that's one of the uses of sort of LLMs was to actually automate that process. So
what's the pipeline there? How does it work?
So I mean, basically, you know that you want to scrape a merchant's website. So the LLM basically works through the process itself. So it looks at the website and then says, how do I get to the product page? And then basically it's working through those steps.
So to fetch the data through regular HTTP GET, like if I was a browser and collect all, to actually scrape the content.
Driving the browser. And
so you develop a robot, a bot that collect content, and what you do with that.
And it's content. It's not their catalog, but it's the content of their sites and any metadata surrounding that. And then that's all shoved into our Redshift and our
into OpenSearch.
OpenSearch even. Yeah. And
so this is kind of vectorized. So you can take all that data that you find and then filter it out, and then all the bits that you're interested in the products, you can put them into a vector database. And then when you want to search for shoes, but what you found is Nikes, it kind of figures out that those are the same thing. So you can have you can have a decent search that returns really good results.
So that's the magic of vectors. Is
It's
that
incredible.
They carry semantic. So
Semantic
for
searching,
each
That's it.
items that you found through the scraper, you compute a vector. You store that vector with the original text in a vector database. And when the user search for shoes or headset or something, you compute again a vector for the search term, and then you try to search for similar or vectors that are close to each other in the
it's like
vector space.
Our VP of data is a nice way of kind of helping people visualize it. Like we use the LLM and the vectors that are created. It's a multi-dimensional space. Like it's hundreds of dimensions that all relate to each other in this vector form. But if you just think about it in like 3D space, you can imagine two points,
segments,
and
of
yes,
lines, vectors.
yeah, exactly,
little groupings in space,
and how near they are to each other, and that's what semantic search surfaces.
And so the user experience is: I go to the Zilch app, I search for shoes,
correct,
and I will get links to the merchants that are selling this type of shoes.
Yep. Shoes as a general like category, and then yes, it will hopefully surface. It'll surface all the ones you know, but then it will also surface ones that you may never have heard of. But the nice thing about that as well is for Zilch as a business, by allowing the app to do that, we can demo that to our retailer partners as well, and encourage them to do direct deals with Zilch. So a shoe store that is not people's first thought, well, now it will at least show up when people search for shoes. And maybe they're going to offer a 10% discount if you pay with Zilch. And it's really nice for our
your
customers.
business is on affiliate commissions. So the more precise you are in that search, the better is it for you for the business, because people can buy from the app. That's
right,
an interesting use of generative AI. It's not about generating text. It's about generating a vector. Side question, are you using AWS Amazon Bedrock?
It's Bedrock with Cohere, I think.
Cohere. I think we have two vector model. It's Titan from Amazon and Cohere.
Yeah, I don't think we switch, because if you think about it, you start with one.
No, you cannot switch. You have to recompute all the vectors.
Yeah. So I don't think.
So
I don't know
switching
if we're gonna,
models. It's a huge decision. It's like a one-way door, we say at Amazon, when you pick up a vector model. Now you are there. You're operating since 2019. You said
that's when we founded, but launched, I believe, 2021.
Okay, so
for 2020,
5 years.
Should check my numbers.
What are the evolution that you're thinking about for the app, for the backend infrastructure? What are the project for this year, next year, without telling me anything which is secret, obviously?
Well, something that people will actually be able to see and experience themselves is we're launching a physical card version of Zilch. So that's going to be really nice. It's going to put Zilch in more people's hands. They'll be able to.
So I will be able, as a customer, to have a card in my wallet.
Yeah. Yes, exactly. Yeah. Which we originally launched with really focusing on the virtual card system, and although that's been adopted really widely, actually, if you look at the broader stats, only 20% of the market are comfortable using the virtual cards. So there's 80% of people out there spending. Of the general public, I suppose.
Surprising.
Yeah. I would expect.
Maybe we're because we're a bit more, insulated in the tech world, exactly. Like, of course, we'll use the virtual card, but lots of people are
what does it change from a technical back-end point of view to issue physical cards instead of virtual one?
Well, there's the whole operational side of that, like the actual postage and replacement and all of this.
Okay.
PIN numbers, I think, as well.
Exactly.
Yeah. PIN number for the card.
Yes. And so you need to provide a way to replace the PIN for people that have forgot their PIN to deliver securely the first time.
Yeah. We have to build an activation mechanism into the app now, which communicates with our issuer. And now we also have to understand behind the scenes the linkage between this virtual card, which we've already issued, and now a physical version of the card as well. And the orchestration of that and linking it back to the original customer is all handled within Zilch. There is plenty of complexity in that.
I think from a technical side, it feels roughly the same. There's a couple of extra details, but like really our infrastructure should handle it the same. I think we're just hoping for maybe more traffic, more volume.
Payment is a payment. When you were coming from a virtual card or a physical card, that part is probably the same. But as you mentioned, there is all the logistic aspect of delivering cards. And on the business side, I guess, for the help
It also
center.
It adds a potential fraud vector that we have to cater for as well. So we have some quite nice fraud controls inside the system, and an internal like custom blocking system as well, where we can block certain behaviors on whether it be the billing or the purchase or the payment for certain customers. And we now have to just expand that a little bit to cater for potential fraud vectors of a physical thing. We've never had to deal with that before. When we first launched Zilch, it was only usable, in fact, when you pressed a button in the app to enable the card. So the card was by default locked. Yeah, locked down. If you tried to use it, you'd be denied. You had to enable in the app for it to work. But as we worked towards more, as our fraud controls evolved, and we wanted to make it way more convenient for customers, now you don't need to do that. You just tap and pay, and but physical's a whole new world now for that.
I guess there is some machine learning involved there as well for the fraud system, and the event-driven architecture is probably used at full there as well, because you can treat a stream of event or related event to detect fraud.
That's right. Yeah, it's evolved a lot. Like, it used to be very discrete in the way that a single event or would trigger something, or we have threshold-based controls, which we still have. But we're now growing into more of an event stream-based system and logic around these frauds, trying to detect patterns in what our users are doing. And actually, Mike can expand on how we're doing that.
Yeah, I think we're trying to look at it, like you said, from a more holistic view. So like the transactions related to other things that are happening.
Before,
after.
In parallel, after.
Exactly. And build out rules, allow the team to build rules that are about things we don't know about yet. So we started noticing some patterns. We want to see if somebody logs in and does something else and then makes a big payment, or does 5 of those perhaps, and we can allow the team to write rules that are fairly dynamic. So we're building that out at the moment with Flink and Kinesis. So we're streaming all the events in, and then we're using Flink to deal with that real-time kind of, or the more real-time aspect of it. And so I think we're trying to get to the real-time, eventually to real-time architecture, which involves some changes in our architecture and how it works. But for the moment, we're doing the Flink side, building up those sort of static rules that a person might make. And then the next step is to use machine learning to try and find those patterns before a human could. So I think that's the next step that we're hoping is. And
if we're trying to we're working in a way where that could then inform the rules on the fly as well, kind of a hot change of rules as events happen. That would be the goal of where we're trying to get to. Yeah.
So you have a team of data scientists, you said, for the semantic search. I guess they are also busy with the fraud system.
Yeah, very, very smart people. They do things I don't quite understand, but
me neither.
Yeah,
that's like black magic.
I do like to ask them lots of questions about all the things they do, but
so the future is around data and machine learning.
Yeah, for sure.
Definitely. It's interesting. It's that as well. It makes you think about events in kind of a different way. You always think of it, event will trigger X, Y, Z. But then thinking about events in sequence, or having a stream, and we're using, we're streaming via Kinesis and Firehose to have that constant flow of events. But thinking how your system responds to that, and say we're experimenting with Flink at the moment to select windows of this event stream to then run logic on. It's just a different way to conceptualize how events are handled.
That's a great conversation about tech. You want to add something?
Just the end result of that is going into S3, so and then into OpenSearch as well. So we can have we can process it afterwards. We can have a look on that side, but also we can search in real time. So we can use all the techniques we talked about earlier in OpenSearch to just look for interesting events and things that are
correlation and patterns.
Yeah, exactly.
Things like that.
So
that's an interesting and fascinating discussion around the tech side of a fintech. So next time you use the Zilch app, if you are based in UK, you will understand a bit better what's happening behind the scene. And if you are not in UK, next time you use a fintech app, you will also think about all the things that happens behind the scene, events, machine learning, semantic search, push notification, in-app push notification, and all the technologies that we talk about. Thank you for explaining all that to the listeners of the Developers Podcast. Mike, your engineering manager, Rob, your VP of engineering of Zilch. Thank you for having listened to this episode of the AWS Developers Podcast until the end. And now go build.